So today we're going to be covering the topic of setting up your autoscalers in your DigitalOcean deployments. So we'll jump straight into getting started on that. So like any other autoscale walkthrough, the first place that this is going to start is over with our zones. We need to make sure that we have our zone configurations set up correctly, elsewise our autoscaled agents won't be able to check in and won't be usable. So we can come in here and you can see it has this kind of placeholder value for our origin domain, our upstream auth address, and our proxy host names. And they're using this request host name value. Now, because this deployment in and of itself is a single zone deployment, I don't actually have to replace like the proxy and the request host name for this specific use case. However, generally speaking, you will need to. And if you are running a multi-zonal setup, of course, then you will especially need to. This upstream auth address will be pointed towards the address for your actual Kasm deployment. So in this case, it would be autoscale.demos.kasmweb.com. And then this proxy hostname down here, this is going to be pointing to your private load balancer or whatever your proxies are sitting behind for your secondary region, and however you're actually going to be connecting into your agents for your sessions. So once you have your zones set up and configured the way that you need them, you can then come over here to your pools, and we'll begin by adding a Docker pool. For our type here, we do offer two different types of pools. You have your Docker agent pool, which is what's going to host your typical Kasm workflow with a Kasm Workspace image. These are going to be your Ubuntu images, your Chrome images, your GIMP photo editor images, and then we also offer a server type. And these are going to be your more static resources or VDI solutions for Windows desktops that you're going to want to be able to access. So we're going to be setting up a Docker pool. Save that. And then in order to set up Autoscale, we need to be able to come in here and click to create a new Autoscale config. But as you can see, we don't actually have that option available to us right now from this pool setting. The reason that that context is missing from us is because currently this deployment of Kasm is not licensed. So the way that we can look and see what kind of license we have currently set on the deployment, we'll come down here to the bottom to Diagnostics, and from here we'll click on System Info. Once at the System Info tab, up here at the top there's a header called Licenses. We'll click there, and we can see that currently there are no licenses applied. I have a temporary license generated by Kasm customer support that I am able to use for a single authentication, and we are going to use that for this purpose. So once we add that there, we're able to see now this page is going to be populated. On our license here, we're able to see when the expiration is, what type of license we have. So here we have Enterprise. And this is necessary because autoscaling is an enterprise-only feature. So you have to have an enterprise-grade license in order to be able to set up autoscale configurations. You can see what type of license it is. At Kasm, we offer per concurrent as well as per user. So you can have a total number of named users or number of sessions launched at any particular time. So now that this license is applied, we'll come back over here to the side menu, go to our Infrastructure tab, and navigate down to the Pools header. Then once we're in here, we can see all of these options down here at the bottom for our DNS providers, VM provider, and Autoscale configs have now all been populated. So we'll come in here to All Autoscale Configs. And this is empty because we haven't configured any yet. So we're going to click this big blue plus button that says Add. Now for the name of your Autoscale config, it's entirely arbitrary and you can name it whatever you'd like. Typically at Kasm, we like to follow a naming convention where we use zone, provider, pool, and then you just finish it off with Autoscale. So what this will tell us is, in context, this deployment is deployed into the Virginia region of DigitalOcean. Our provider is going to be DigitalOcean. I don't want to type all of that out, so I'll just put DO for DigitalOcean. Our pool, this is going to be a Docker pool, and then Autoscale, just to bring it all around. So for our Autoscale type, we'll select our Docker agent type. For our pool, we'll select that Docker pool that we just created. And then deployment zone, you would put this in whichever prospective deployment zone that you would want to, whether that be a US Virginia zone, that be a Australian Sydney zone, or we also use zones for non-region specific workspaces that have a siloed structure. So you might need to have zones set up for different types of organizational structures within your company or within your department for maintaining security and least privilege. So we only have the one deployment zone, which is default. So we'll go ahead and click on that there. Now for our standby cores here, what the standby cores and all of these standby values actually tell Kasm is how many resources should be ready and available at any given point in time for users to be able to request Kasm sessions. Looking at the standby core values here, what all of these represent is how many resources are currently available on an agent for users to be able to use to request new sessions. So to visualize what this kind of looks like, we have this helpful little graphic here in which we have a brand new agent that's just been provisioned and is completely empty here. So we can see here that we have given this agent 6 cores and 12 gigabytes of memory. Now, as we continue to use this agent and load up sessions on it, you can see here we've metaphorically loaded up a Ubuntu workspace as well as a Chrome workspace. Now, note here how the Chrome workspace is using less resources than the Ubuntu workspace, given that the Chrome workspace does not have to carry as much of a load as the full desktop Ubuntu workspace does. Now, whenever we populate this agent with these workspaces, what we can actually see is that the standby cores, which are the available 6 cores and 12 gigabytes of memory that we originally provisioned it with, are able to drop down to 0 as it fills up with workspaces. So whenever we provision a 2 CPU and 4 gigabyte Chrome session, it subtracts 2 CPU and 4 gigabytes of memory from the standby cores, bringing the standby cores over here down to 3 and down to 8. Or no, sorry, that brings this down to 4 and down to 8. Math is very important. And then once we launch our Ubuntu session, we will be able to utilize that last remaining 4 CPUs, bringing it down to 0, as well as our last remaining 8 gigabytes of memory. Now, in the context of Kasm, whenever it sees that the standby cores value right here has been breached, so let's go ahead and set our standby cores value to 4 and 6. Or no, we'll do 4 and 8. Ultimately, I want to make sure that at any point in time, I have enough resources available to be able to provision a brand new Ubuntu workspace. So whenever we set this to 4 and 8 with 0 GPUs, then as we have this agent sitting here ready and available, as these Kasm sessions fill up and this number drops below 4 cores and 8 gigabytes of memory, it triggers a scaling event in which Kasm will deploy a new VM resource in your cloud provider of choice in order to give you more availability. For this downscale backoff, this covers basically the amount of time in which these thresholds set above in the standby values Once that threshold is breached, how long will Kasm allow for those thresholds to be breached before that scale action takes place in order to scale resources back down? So we talked about how a scaling action happens if there's too few resources available. Now, on the flip side of that, if we want to start talking about how Kasm is able to reap unused resources in order to maintain efficiency and save costs, that's where we begin looking at the downscale backoff. So with these thresholds defined by the standby memories, these are going to define what should be available at any given point in time. And Kasm is going to try as closely as possible to make sure that these resources are available depending on what your agent sizings are. So if, going back to our example here, we have our nice empty agent here, and then we load up an Ubuntu workspace session. That is going to drop here. So we have our busy agent, and we load up a Ubuntu workspace session. That is going to mean that our cores drop to 2 CPUs available, as well as 4 gigabytes of memory. So Kasm is going to see that these values no longer fall within this threshold, and thus it's going to scale up, and it's going to give us an entirely new agent. Now, say the user who initiates this Ubuntu session decides that they no longer need their session, so they kill it off. So this agent is no longer busy, and it now has 6 CPUs and 12 gigabytes of memory available. This brings the total available standby compute to 12 cores, if you look across both our agents that have been provisioned here. 12 cores, as well as 24 gigabytes of memory. Now this is obviously well above the threshold defined by the standby compute. So Kasm is going to need to take this empty agent back and terminate it in order to optimize costs and maintain efficiency. The downscale backoff is what defines how long it actually takes Kasm to decide to take that agent back offline. If you have users that are popping on and off of your Kasm deployment, you may want to make your downscale backoff timer a longer amount of time in order to provide your users with the ability to continue to respin up sessions without having to wait for more resources to be provisioned. A scaling event from Kasm can take anywhere from 2 to 5 minutes, depending upon how the resources are requested and if the scale event is initiated by Kasm or initiated by a user trying to request a session. Okay, so for our downscale backoff, we'll set this value to 3600 seconds, or the equivalent of 1 hour. Now, your override values are very similar to your standby values, and they work in correlation, as such that your core override values is what's going to actually present Kasm with the number of resources available to you, regardless of what your VM actually has present. So for example, say we want to provision a brand new agent that has 6 CPUs and 12 gigabytes of memory. Via our agent core overrides, we're actually able to oversubscribe the resources available on that agent for the ability to use more Kasm sessions and virtually split that compute into more resources so that we have more available to us. So our agent is going to have 6 vCPU physically. However, if we want it to have more CPUs available to that, then what we can actually do is we can set this agent core override, and whereas typically it's going to have 6 CPU, I can actually set this to 12, and then Kasm will think that our agent has 12 CPUs available to it. It's very important that you use caution when using these override values, as these are one of the leading causes of system instability in your Kasm deployment. If agent resources are over-provisioned from what is actually physically available on the agent, it can lead to a loss of performance, connection instability, and an overall poor user experience on your Kasm deployment. So for our memory here, I'm just going to go with what we're provisioning it with, and that's 12. For these Nginx certs fields, these are necessary for a direct-to-agent workflow. A direct-to-agent workflow is whenever you are connecting directly to your Kasm agent actual's VM in order to access your Kasm sessions. Another common workflow that we use is setting up our Kasm agents behind a NAT gateway, so we're able to navigate to it through the NAT. In which case, we don't need the Nginx certs to be located on the agents themselves, as that's going to be completely taken care of by our infrastructure. So for this, since it's a required value, we are just going to put a single space in each of these fields in order to satisfy the required constraint, and then we'll hit next. On our VM provider config screen, we're going to create a new provider, and then under provider, we're going to select our requested provider. In this case, it's going to be DigitalOcean, because that's where the rest of this autoscale.demos.kasmweb.com deployment is located. So for our providers, we like to use a similar naming convention as what we use for the actual Autoscale details. And so we like to use our region or zone, our provider, and our pool. And then I usually just name it VM provider at the end. For our token here, we will need to get this from our DigitalOcean deployment. So I am going to load up our DigitalOcean. So from your DigitalOcean home screen here, we're going to need to generate a new access token for Kasm to be able to interact with our DigitalOcean environment. In order to generate a new API token, over here on the left-hand side context menu, we'll come down to the API tab. And then in here, it'll open up to this personal access tokens page, in which we will generate a new token. So we'll name this Autoscale Walkthrough. And we're going to set this expiration to the earliest that we have available here, which is 30 days. However, this token will actually be deleted as soon as this walkthrough is over. Now, for your scopes, you can either create a custom scope, which will allow you to scope the necessary permissions for this user to what is necessary in order to be able to actually deploy the resources in your environment, in which case you'll need access to your certificates, your database, your firewall, your load balancers, project, regions, sizes, SSH keys, tags, VPCs, images, droplets, domains, and I believe actions? Actions, because we need read access. Now, I believe that this is a good place to start in terms of your access, and this could probably be scoped down a little bit as well for updating. You probably don't need to update the domain, you only probably need to be able to read it. You definitely don't need to be able to create it either. But using this scope here, we are going to go ahead and generate our token. We'll go ahead and copy this. Make sure you save this token in a secure location, as once you leave this page, you will never be able to see it again. Going back into our Kasm environment, we're going to go ahead and paste in our token there. For this max droplets argument here, what this is going to control is the maximum number of agents that can be provisioned at a single point in time. This setting is mostly useful for preventing runaway agents in the event that your deployment gets into a bad state. This can also be very useful for making sure that your deployment stays within bounds in terms of budget and cost spending. As a general rule, we like to set this to 10 here at Kasm. However, your specific use case and your team's needs will define what this max number of instances will be set to. For our region, we're going to come back into DigitalOcean, come to our droplets, and then we're going to want to look and see where all of our other resources have been provisioned. So we can see here that these have all been provisioned into NYC3 as our region. So we'll go ahead and grab this. Should be NYC3. For our images, DigitalOcean actually offers some pretty good docs that you can navigate to in order to look and see what the different images that they offer are, as well as be able to get the API slug, which you'll need to provide to Kasm. For the purposes of this, we will be using an Ubuntu image, and we'll go ahead and get Ubuntu 2204 because that happens to be my favorite personal distro. For our droplet sizing, what we're going to do is we are going to come back into DigitalOcean to our droplets here, go back to our droplets, and we will create a new droplet. I personally find that creating a new droplet is the easiest way to be able to customize it for exactly what you are needing and then to be able to get the specific size. So for their options, they offer a variety of different types from your regular shared CPU droplet, which is going to be your most cost effective. However, for your Kasm deployment and for agents, I would highly recommend using dedicated resources for your agent, and generally a general purpose dedicated CPU instance would be ideal for the use case. So looking at our options here, we will go with an actually CPU optimized workload in which we are going to get 4 CPUs and 8 gigabytes. Or conversely, we could set up this one with 8 CPUs and 16 gigabytes. The most important thing when selecting a size for your agents is, again, just to keep in mind the workflow that you will be using Kasm for and the general sizing of what your workspaces will be. Keeping in mind, of course, like we mentioned in our drawing earlier, different workspaces do have different levels of requirements for resources. Once we've selected the size that we want, up here at the top, we can actually see our size being passed in as an argument in the URL bar. So we're able to grab our sizing up here. We can actually see this is following a standard naming convention for C for CPU optimized, and then 8 for the number of CPU cores that we have available to us. If we were to choose the CPU optimized plan with 4 CPU, we can see that this size is going to drop down to C4. And if we were to take a look at our memory optimized, we can see that this name up here changes, and you can see the entire family changes from a C to an M. Once again, the naming convention for all of these different families can be a little bit tricky. Easiest way to find your perfect sizing is to simply just come into the UI, select your preferred sizing down here, and then get it from up top. Additionally, DigitalOcean does offer some pretty good documentation on their different CPU families and what you might be needing for that. So in here we'll put C8. Tags, you're able to pass in any sort of tags that you want for your environment. They're not necessary, and because these resources won't be living long-term within our environment, I am not going to put any tags on it. So next we'll need an SSH key name. In order to get the SSH key name, you're actually going to have to upload some SSH keys into your DigitalOcean environment. And the way that we'll do this is from your home screen in DigitalOcean, left side context menu, we're going to come down to the Settings tab. From here, we'll go to the Security header, and then we'll see our SSH keys. You'll come over and select the blue Add SSH Keys button, and then from there, you will generate a new SSH key following the instructions available to you on the right, and then paste that SSH public key over here in the context on the left, add key, and then it'll become available to you here. So you'll just get the name that you provided for your key. We can see here for my key, which was already provisioned for my Terraform user, this name right here. So we'll go ahead and copy that and then move that over to our Kasm deployment. Now, for our firewall name, we will have to do a similar thing, just coming in and grabbing the name. So back in DigitalOcean, I'm going to come over to the left-hand context menu and then go down to our networking tab. Once in our networking tab, we're able to go to our firewalls header up at the top. And then all of your firewalls will be listed out here. We can go ahead and select our firewall here, named Autoscale Test Firewall, named after this project. And then finally, we will need our startup script. We do offer in our public GitHub all of our startup scripts for all of our publicly available Terraforms and Terraform providers. So in order to get to that, you can navigate to this link, which will be available in the video description, as well as coming into GitHub, searching for the Kasm Tech organization, and navigating to our Workspaces Autoscale Startup Scripts repo. Once in the repo, you can go ahead and select the Kasm version that you are running. So our deployment is going to be running 1.16.1, so I'll navigate into here. We are going to be needing to set up a Docker agent. And then finally, we're going to want to get our ubuntu.sh. Now, this startup script here is made in a way that it is agnostic to your provider. And so you can see in here we have all of the options available for AWS, for GCP, DigitalOcean, OCI, Azure, vSphere. And we'll have to make some slight adjustments to this in order for it to be applicable for our DigitalOcean environment. So once we get this, we can come back into our Kasm deployment, and the startup script field down at the bottom can actually be expanded to help make editing a little bit more easy. What you'll do is you'll just hover over the bottom right-hand corner and then click and then drag it down. Now that we've pasted in our startup script, we can see all of our variables defined at the top with this bracket variable bracket notation. On face value, you may assume that this is actually going to be incorrect syntax, as you may be used to regular bash syntax in which you have to have a $ parentheses. Whereas these variables are actually going to be interpolated by Kasm whenever it's sending this startup script over to your provider of choice to provision your new machine. So it's going to replace all of these values with system values, which can be configured within your settings tab. So to make the necessary adjustments that we need for DigitalOcean, we'll come down here to our IP definition, and we'll go ahead and comment out this default IP address. And then we'll come down here to DigitalOcean, and we're going to go ahead and uncomment our DigitalOcean public IP check. Next, since this environment won't be using a direct-to-agent workflow, and all of our agents are going to be sitting behind a NAT gateway, we aren't going to need our Nginx certs to be on the agents at all. So, scrolling down to the very bottom of the startup script, we're going to go ahead and comment out both of these echo commands here. What this does is this is going to take your Nginx key values that you input on the previous context screen, and it's going to go ahead and interpolate those values in and then echo them into your actual cert key file. It's important that if you do not have a direct-to-agent workflow, that you comment these out, as elsewise it will replace the private cert located on the agents with the plain space that you inputted for the Nginx field on the previous screen, which will result with the inability to connect to your agents and errors within your Kasm deployment. So with this, we are actually done with our Autoscale setup, so we can click Finish. And then once this is finished, Kasm will continue to do its thing, and once every minute, it's actually going to check how many resources are defined in any of the Autoscale configs versus how many are actively available as Docker agents. And it's going to go ahead and provision more agents in order to reach those thresholds as defined by the standby resources. So now we just have to wait a few minutes while Kasm does its thing, and then we'll check back in to see our agents coming online and checking in. Yeah. So now we can see in our Docker Agents tab our new agent that is being provisioned and coming online. It has a null value for its host and many of its values currently, and that's just because it has not checked in yet. So it just needs a little bit of time to continue coming online. Once it checks in, we'll be able to have a connection IP for the host name. So this came online. You can see it came online. It says 4 minutes ago. It's probably like 7 now. 7, 8, 7. So this came online, but it never checked in. So what I then did is I SSH'd into the node. Then once I was in here, I did a sudo cat on varlog cloud. Well, now it's not going to work. Let's do sudo tail /in50. So this is a tail with the last 50 lines. Var log cloud. Oh, I disconnected from that instance. Sudo tail /in50 var log cloud-init output.log. So this gives us the full log from this user data script whenever it first runs. And we can see here it pulled down our images just fine. Looks like it installed Kasm just fine. But then whenever it got to do a connectivity check for our web app, it wasn't able to do so. Now we can see here trying proxy health check. This kind of gave me an indication straight off the bat that our variables weren't being interpolated incorrectly because it says proxy here. Typically this proxy API check, this is going to be using trying, and then it passes in the manager URL health check and then the attempt of connecting to it. So this told me that for manager URL we're getting proxy, which obviously is not going to work unless you're using the single server proxy agent. As if you're using the proxy agent, it's fine, but since we're using Autoscale, it's not. So then I confirmed that by coming in here and doing a sudo cat var lib cloud instances tab, because there's only going to be one folder directory in this instances directory, which is your instance. And then in here, you can go to userdata.txt. And then this is the script that we passed in from Kasm. So this is the user data script. And up here at the top, all of these variables, which I had mentioned previously, are being interpolated by Kasm. You can see the values that they pushed in here now. So for our hostname, have our Kasm hostname, FQDN manager token. For our manager address here, we can see definitely it's passing in proxy, which is not what it should be. So I realized that I was actually wrong earlier whenever I said that I did not need to change the zone configs, because while I am using a single server deploy, the agents aren't a part of that single server, so they can't use a proxy upstream auth address. So I went into the zone and I fixed that. And then now DigitalOcean should be trying to provision a new droplet any time now, and this new droplet will then have the updated pool information. Okay, and then on this agent here, we're able to see the install actually happening. So I went ahead and I just SSH'd onto this one as soon as it came online. And so now we are just watching the user data and cloud-init run. Then we can see here our cloud-init has finished successfully. So then if I come out here and I run a Docker PS, we can now see that our Kasm agent and Kasm proxy are up and running and healthy, which means if we come over here back to our deployment and we refresh here, we will have our agent has fully checked in. Okay, and so then with that, that will conclude the end of our DigitalOcean Autoscale walkthrough.